They fixed it. Alright. Number one. Actually, first thing I want you guys to do is write down these equations. And this is nicely off camera so nobody can see who's watching down there. This is going to be delta y equals 1/2 VO plus VF. T, you have these written down somewhere else, but it's nice to have them on your sheet of paper. Delta y equals VOT plus 1/2 G T squared. VF equals VO plus GT. VF squared equals VO squared plus 2G delta y. And what's G always?
Gravity.
Gravity, and what number is it? Negative 9.8. Alright, number one. First problem is kind of tricky with this, to be honest. Ball is thrown up with initial velocity of 15 meters per second from a 23 meter high cliff. How long did it take to hit the ground? So the ball goes up, comes down, hits the ground. Alright, there's lots of different ways to do this problem. One way would be figure out how long it takes to get to the top, figure out how high it went, and then figure out how long it would take to get to the bottom from there. But that's 3 equations and it takes a little longer. We can also just consider this one thing and to go up and come back down in just one step. There's a problem with that we'll get to in a second. So that's what we're going to start with though. So overall here, what is our displacement? This is 23 meters high. How far is it from where it started? What? Is it going to be positive 23 or negative 23? Negative, since I'm asking about it, right? And it's negative because you're below where you started. So anytime it's going down, it's negative. Anything going up is positive. Does that make sense to everybody? Alright. What else do we know? What's our initial velocity? 3 meters per second. Is that up or down? Up, so it's positive. Does that make sense to everybody? And what's gravity? You're 9.8 meters per second squared. And we're looking for time. Alright. Does everybody understand what those variables are and why they are what they are? And just, I know this is something that confuses people sometimes, because we made 15 positive and going up, and delta y negative 23 going down, we're incorporating that part there as well. Does everybody understand that? Alright. So, what equation has those 4 things? You're going to say first, second, third, or fourth? Second. So negative 23 equals 15 t plus 1/2 equals negative 9.8 t squared. What do we have to do to solve that for t? Since we have a t and a t squared. What is that?
Factor out t.
Can't factor out a t. Because we have a 23 on the other side. Austin's?
So I set it up so it's quadratic.
Set it up so it's quadratic. Who wants to do the quadratic formula? No one? We don't have to use this equation. You can do this with the quadratic formula, and you get 0 equals negative 4.9 t squared plus 15 t plus 23. and you'd solve for t, and you'd get a positive and negative t, and we'd go from there. Are you guys going to want to do that on the test? If you have the quadratic formula programmed into your calculator, I'm perfectly okay with you doing it that way. Does anybody have that? When do you guys want to solve this real quick with your calculator, and we'll get an answer anyway? Just so you guys can see I've done that. I'm going to show you an alternate way to do it without the quadratic formula. So if you want to be friends with either Austin or Emery, I have a linking cable and you can get the quadratic. It does make it a little easier, but it's not significantly so. It's just one less step.
Negative 1.12 is 4.18.
So which of those is our answer? 4.18, because time can't be negative. What that negative 1.12 means, that in an imaginary situation, if you threw it from here up, it would take 1.12 seconds to get to the top of the clip. So if you go back in time, where you can't actually go, to where that would be where delta y is 0, like you get to the bottom again. You don't really need to know that, but it's always going to be your positive answer. So that's the answer. Alright, alternate way to do this problem. We can use these three things to find VF, and then use that VF to find time. So what equation has final velocity without time? Third one is going to be VF squared equals VO squared plus 2G delta Y. We have VF squared equals 15 squared plus 2 is negative 9.8 times negative 23. Somebody do this math and tell me what VF squared equals. And then what is our final velocity when you take the square root of that? Alright. From a math perspective, what are we missing in front of that VF since we took the square root of it? Plus or minus? Is the ball going up or going down right before it hits the ground? Down. So should that final velocity be positive or negative? Negative. It equals negative 26 meters per second for our final velocity. Now we have a couple of choices for what we can use to find time. I'm going to just use this one. So we get VF equals VO plus GT. We get negative 26 equals 15 plus negative 9.8 times t. So we get negative 41 equals negative 9.8 t. And what does t equal? Questions about that? Does that make sense to everybody? Awesome.
So, because the original velocity was 15 meters per second, and delta y was negative 23, that factors in.
That factors in the up and down part. let's do number 2. This is another one with lots of different ways to do it. Alright, a ball is thrown up with initial velocity of 12.7 meters per second. How long is it in the air for? And it's coming, we are assuming it's coming back down to the same height here. Does that make sense? So for number 2, what is our delta y?
0.
0. Does that make sense to everybody? What is our initial velocity? What is 12.7? And that's positive, and g is negative 9.8. And we're looking for time. I'm going to do this a couple different ways again, just because it'll show you a couple of important things. Alright, what's the velocity of this at the highest point? 0. When you're going up and back down to the same height, like you go like the same distance up and down, it takes the same amount of time to go up and down, and you go the same distance up and down. So if we can figure out the time to get to the top and multiply it by 2, that'll give us the total time in the air. Everybody understand that? So we're going to do it that way first, and we're going to probably an easier way second. So if we say F equals 0, but now delta y does not equal 0, so we can't use that. So we have VF, VO, and G. What equation can we use to find time? Third one. We do VF equals VO plus GT. 0 equals 12.7 plus negative 9.8 times T. Negative 12.7 equals negative 9.8 T. And T equals 1 point something. 1.34, I guess. What does it equal? 1.3. Alright. What do we need to do to that? So that's the time it takes to get to the top. What do we need to do to figure out how long it takes to go up and down? So this is the same height. Multiply by 2. So times 2. So our answer this way would be 2.6 seconds. That way, it's a little bit, it's probably ultimately quicker, but you just have to remember to multiply by 2. That's probably the fastest way to do it because that equation is pretty simple. Other way to do it is to use the variables we had and say delta y equals VOT equals 1/2 GT squared. And we get 0 equals 12.7T plus 1/2 times negative 9.8 times T squared. So we still have a T and T squared, but now what can we do? Instead of having to use a quadratic. Awesome. Factor out a T. So we can say 0 equals T times 12.7 plus minus 4.9 T. Does that make sense to everybody? And what can we do to solve for T here? We're just going to set this equal to 0, right? So one of our T's equals 0. That's not our answer though. And we say 0 equals 12.7 minus 4.9 T. And what does that other T equal? is very close to 2.6. Questions about that one? Alright, I'm just going to tell you about 3, then we're going to do number 4 together. Number 3, a rock is thrown downward from the top of a cliff with an initial speed of 13 meters per second. If the rock hits the ground after 2.6 seconds, what is the height of the cliff? That's almost just like number 2, except it's easier since you're not having to do time, so you don't have to worry about the quadratic or anything like that. But the one here is, since the rock is thrown downward, what do you make initial velocity? Negative. So you guys will do that one in a second on your own, but let's do number 4 together. A falling stone takes 2.7 seconds to travel past a window 2.4 meters tall. From what height above the window did the stone fall? So we're assuming it's dropped here. Initial velocity is going to be 0. But Alright, so this is one of those that we're going to have to divide up into 2 parts. What 2 parts are there going to be? Emery?
Before the window and bring one.
Yep, so before the window. And at window. Okay, what do we know about before the window? Like I said, assuming it was dropped, so Austin's.
T. Well,
No, the time is for how long it takes to go at the window, like past the window. So before the window, what we know is our initial velocity is 0, because it was dropped. We also know g equals negative 9.8 meters per second squared. That's all we know. What we're ultimately looking for in the problem is delta y for before the window. Does that make sense to everybody? What about at the window? What do we know? What's our time?
0.27 seconds.
0.27 seconds. We know delta y is what?
2.4.
2.4. Is that positive or negative? Negative, because it fell that far. And we know g is equal to negative 9.8 meters per second squared. Okay. So we can solve for stuff with the at the window part, but we can't solve for anything before the window. And that's what we need. What from the at the window part that we can solve for will be useful for the before the window part?
Initial velocity.
The initial velocity of the at the window part is going to be what for the before the window part? Final velocity. So we're going to say, over there. We're going to find VO over here. What equation can we use? Second one. Delta y equals VOT plus 1/2 GT squared. We get negative 2.4 equals VO times 0.27 plus 1/2 negative 9.8 times 0.27 quantity squared. Negative 2.4 equals VO times 0.27 minus, what's that equal to over there?
Negative 0.257.
Add that to this side, we get negative 2.657 VO 0.27. What does VO equal?
It's 0.357.
Oh. initial velocity. Does that make sense to everybody?
You add the. You would add the 0.25 seconds, shouldn't it be 2.1?
Thank you guys. So what would that equal on the other side? I'm sorry guys.
2.43.
And that probably changes this since I messed up. There we go. I apologize about that. So this DO from over there is 7.57.
Isn't it negative?
Thank you. I got cold today, I'm not quite with it. That makes sense, it is falling. So now what equation do we, that has all four of those variables in it? BOG, delta Y, and BF. Fourth one, so we're gonna use BF squared, BO squared, plus 2G delta Y. BF is negative 7.57 meters per second. 180 squared equals 0 plus 2 times negative 9.8 times delta Y. What we're finding here is how far it actually fell, so we're going to get a negative number, and it's just going to be equal to how high the window is. What's delta Y?
Negative 2.92.
So that's our answer. I'd accept negative 2.92 as well. It means the same thing. You just found that it fell 2.92 meters, so it came from 2.92 meters above the window. Alright, anybody have any questions over this one? To see how a lot of this is kind of the same tricks from before, you just have to divide it up in the correct way, and then it doesn't become too hard. Alright, why don't you guys try the rest on your own? And answers to everything are in there. And you guys can again work with anybody you want. If you want to turn around and work together, that is perfectly acceptable. I should turn this off now, huh?